Friends, welcome to this class. Today we are going to study Stoke's theorem. Please see this some information about the Stoke's theorem. What is Stoke's theorem? Stoke's theorem says that the line integral of a vector around any closed curve is equal to the surface integral of the normal component of the curl of the same vector over a surface S. So what basically it is converting a line integral into a surface integral. So mathematically, if A is a vector and the line integral of that vector over any closed curve is equal to the surface integral of the curl of that same vector over a surface. So that means the line integral is basically over the boundary of the surface. So the path of the line integral should be the boundary of the surface, which is used for taking the surface integral. ഒരു വെക്ടർ ആ വെക്ടറിനെ ലൈൻ ഇൻ്റഗ്രൽ എടുക്കുകയാണെങ്കിൽ ഒരു ക്ലോസ്ഡ് എന്ന് പറഞ്ഞാൽ സർക്കിൾ പോലെയുള്ള ഒരു കർവ് ഒരു വൃത്തത്തിൽ നമ്മൾ ഒരു ലൈൻ ഇൻ്റഗ്രൽ എടുക്കുകയാണെങ്കിൽ ആ ലൈൻ ഇൻ്റഗ്രൽ ഒരു സർഫസ് ഇൻ്റഗ്രലിന് തുല്യമായിരിക്കും. അതേ വെക്ടറിൻ്റെ സർഫസ് ഇൻ്റഗ്രൽ അതേ വെക്ടറിൻ്റെ കേളിൻ്റെ സർഫസ് ഇൻ്റഗ്രലിന് തുല്യമായിരിക്കും. നമുക്കറിയാം കേൾ എടുക്കാൻ ഉപയോഗിക്കുന്നത് ഡെൽ ഓപ്പറേറ്റർ ആണ്. So in other words, the surface integral of the curl of the function over a surface, that surface which is bounded by a line, is equal to the line integral of the particular vector function around that surface. So here you can see there is a line and there is a surface. So if you integrate the vector over the curve, that is line integral, that will be equal to integrating the curl of the vector over the surface. See here, what is C? C is a closed curve, but S is any surface bounded by the C. S is not a closed surface. It can be any surface, but it is bounded by the closed surface. Now I have a vector force F whose components have continuous derivatives in an open region containing surface. Now according to this, what we can say is this is the statement of the Stoke's theorem, mathematical statement. So if I take the line integral, this is the line integral, that is equal to, that line integral should be closed. This line should be closed. But the surface integral may not be closed. This is not closed. The only condition is this surface should be the boundary of this closed curve. നമ്മൾ എടുക്കുന്ന കർവ് ഈ സർഫസിൻ്റെ ബൗണ്ടറി കർവ് ആയിരിക്കണം. You can see here the surface is bounded by this curve. This is the curve. This is closed. So it has to reach the starting point, but the surface is not closed. So if I walk in the positive direction around the curve with your head pointing in the direction of n, the surface will always be on your left. See here, the surface is on your left. If I walk from the boundary of this surface along the direction of this arrow. So what is S? S is an oriented smooth surface bounded by a simple closed smooth boundary curve. This is what another form. This is also, we can say in this form, the curl of a vector, and whose surface curl of a vector is a vector. So I am taking the surface integral of the curl of a vector. That will be equal to the line integral of the vector. So if I want to prove this theorem, we consider that a surface is divided into infinitesimally small surface elements having boundaries. So boundary of each element is traced out anti-clockwise. So you have this surface, and this surface is divided into lot of this is the closed curve, and this is having a closed surface, and let us say this is divided into a lot of small surfaces. This is surface elements, and the surface elements have got boundaries, and it is having anti-clockwise direction traced out it. So if I take the dot product of the curl of the vector and the surface of the element area, so that will become that will become is sigma for all the surface. If I take, it will be sigma del cross A dot K delta S. So according to the Stoke's theorem, this is what the statement looks like, because I am integrating the vector over a closed curve, but that is what equal to the sum of the surface integrals. But you can see here all the integrals within the interior of the surface cancels, because the two integrals are in opposite direction along the common side between two adjacent area elements. So you can see here this element, uh, so in this area, the small infinitesimal area, this line, so when I take the line integral, or when I take the surface integral, this direction and this direction are in opposite directions, so they will cancel out. So the only portion of the line integral that are left are those along the sides which lie on the boundary. So you see a problem or example. I have a function or a vector. I want to prove this Stoke's theorem. First of all, the surface is the part of the sphere that lies inside a cylinder and above the xy plane. So we have to evaluate this curl of a vector over a surface. It is not closed, but the surface is the part of the sphere. It is not a complete part of the sphere. Whatever the part of the sphere that lies inside a cylinder. So I have a cylinder, and another condition is it should be above the xy plane. The cylinder should be above the xy. The condition is the part of the sphere should be above the xy plane, and the part of the sphere that should be within the cylinder. Now, what is the cylinder? The cylinder is given x square plus y square is 1. The sphere is also given x square plus y square plus z square is 4. Now, if I try to draw the picture of this, this is what the sphere looks like. This is the sphere and this is the cylinder. So the cylinder has got a radius of 1 and the sphere has got a radius of 2. So this is 2 and this is 1. This is 1. Now, what is the surface which they are saying above the xy plane? So this is the above xy plane and within the cylinder. So the sphere, the part of the sphere within the cylinder, that is the surface. The yellow colored surface is only what this means. Okay. Now I was subtracting the second and third first equation. Z square is equal to 3. Z is equal to root 3. Now the circle is x square plus y square is equal to 1. And Z is equal to root 3. That is the position of the circle. Now I am writing the curve which is bounding the surface. So what is the curve which is bounding the surface is, see here, I am writing the x component, y component and z component. Along the x direction, cos t, that is a vector, that is an angle. Cos t means an angle in the x direction. So that means, so if I have an angle t, this is t, so cos component will be in the x axis, plus sin t. Sin t will be in the, sorry, it has to be like this. It has to be like this. It has to be like this. So this will be t. So this will be t. So this will be the y component. This will be the x component. So this is cos. This is cos t, and this is sin t. Plus root 3k. This is the z axis. So this point is root 3k. So if I differentiate this, what I get? Minus sin t plus cos t. Now, if I write this force as f of rt is equal to root 3 cos t I plus root 3 sin t j plus, so what will be this force? The force is given as x z. The value of x and z are given, are to be written. X z. X is root 3 cos t. Okay, x is cos t and z is root 3, and then I put the value of z and y, and then I put the value of the component of along the z direction, cos t sin t. So now this t is an angle which is between 0 and 2 pi. So if I have written this force in terms of t, that is an angle, so the range of this will be, limit of the integration will be 0 to 2 pi. So 0 to 2 pi, I have to find the integral, line integral. So I don't want to find the curl of this vector. Instead of finding, if I want to find the curl of the vector, I just have to find the line integral of the vector. So just I put the value of force in the terms of this, and then I put the value of r dash. So what is f? That f value I have put here, and then I put the r dash value from here. So I have r dash and f. But here, if I take the dot product f and r dash, only I component and j component are there. K component is not there. So there is no k component. If I take the dot product, I have only two terms. K component is not there. So if I integrate, it will be again sin and cos. It will be again sin and cos. So if I put the limits 0, this will become 0. If I put the limit 2 pi, that will become 0, because sine of 0 is 0, sine of 2 pi is 0, and cos of 0 is 1, and cos of 2 pi will be. So because another thing is that if I integrate this, only sine term will come, so that sine term will vanish out if I put the limits. So the answer is the curl of this vector is 0. So this is the answer. So this is how we are proving the Stoke's theorem. Thank you on and all. And one more thing we can say is, if I have a line integral 0 over a closed path, then A is called irrotational. That means if I know the line integral, automatically we can say if it is 0 line integral, then we can say the cross product, or the curl is 0. Curl means irrotational. Curl is 0 means there is no rotation. And if a vector denotes the force, and then if that force line integral is 0, it means the total work done by the force in taking the body around a closed curve is 0. So that means the total energy remains conserved throughout the motion. So what is the practical purpose? It is used for determining whether a vector field is conservative or not. It allows one to interpret the curl of a vector as a measure of swirling around an axis. So that means you can interpret what is the meaning of curl of a vector, and we can use for determining whether a vector field is conservative or not, because for a conservative field the work done over over a closed path is 0. That is, work done means line integral of a force around a closed surface.